So this is the second video of the fill in the blank proofs and also an introduction some more to flow proofs. Okay, so looking here, we're given that angle 1 and angle 2 are straight angles. We want to prove that angle 1 is congruent to angle 2. So first in our statements, we write what we know. So statements angle 1 and angle 2 are straight angles. And that's the reason is given. For statement 2, the measure of angle 1 equals 180 degrees, and the measure of angle 2 equals 180 degrees. And that's because of the definition of a straight angle. Right? We know that straight angles equal 180 degrees. So this tells us the measure of angle 1 equals the measure of angle 2, and that's by the substitution property of equality, right? Because we know that we can just plug them in. We see here that we have measure of angle 1 equals 180 and the measure of angle 2 equals 180. Therefore, measure of angle 1 has to equal measure of angle 2. Last, we have a reason in the definition, or that we have a statement that's blank, and the reason is because of definition of congruent angles, and not saying that because the measures are equal, that the measure of angle 1 has to be congruent to the measure of angle 2. Okay, so now we're looking at another one. Angle JKL is a right angle, and we want to prove that angle 1 and angle 2 are complementary angles. So for the statement JKL is a right angle, what's the reason for that? Well, it's given to us. Now we have something blank, and I have a reason being the definition of right angles. So what's the definition of a right angle? Well, that must mean that measure of angle JKL is equal to 90 degrees, right? Because the definition of a right angle says that all right angles are equal to 90 degrees. Now we know that the measure of angle JKL is equal to the measure of angle 1 plus the measure of angle 2, and that's by the angle addition postulate. We also see that 90 degrees is equal to the measure of angle 1 plus measure of angle 2. Well, how did we incorporate this idea here and this idea here? Well, I see right here that we have the measure of JKL. That means I can substitute 90 in for that. So that's just by substitution. All right, so now we know that by the definition of complementary angles, that angle 1 and angle 2 are complementary. All right, when we think about proofs, we always want to start off with whatever's given to us. So always this first statement. At the end of our proof, we should always make sure that our last statement is exactly what we're trying to prove. All right, and then all the reasons in between help you get from point A to point B. Okay, now we have this one. So given that segment AB is congruent to segment BC, and that segment BC is congruent to segment DE, prove that AB is congruent to DE. Now, I'm given information, I have a diagram, what do I do? Well, I mark it up. So if AB is congruent to BC, and BC is congruent to DE, we need to go from there. So the first statement, we need to see, okay, it's given to us. So that means that AB is congruent to BC and BC is congruent to DE. Now, this tells me that AB is equal to BC and BC equals DE. Notice how these don't have those lines on top? Because we're talking about their distances. So that's by the definition of congruent segments. If two lines are congruent, then their distances have to be the same. So now we see that AB is equal to DE. And how do I know that? Well, I know that by the transitive property. All right, and remember that's if A is equal to B is equal to C, then A is equal to C. So that's the same idea. AB, BC, BC, DE, AB, DE. And then last but not least, the segment AB is congruent to segment DE and by definition of congruent segments. All right. Given V is the midpoint of SW, W is the midpoint of VT, prove that SV is congruent to WT. So if I know that V is the midpoint of SW, and I know that W is the midpoint of VT, I'll put lines like this, prove that SV is equal to WT. So first, V is the midpoint of SW. Well, that's given. Statement 2 would say W is the midpoint of VT, because that's given to us. Now, definition of midpoint. What do you think we're going to put there? Well, I think that this says that SV is equal to VW and VW is equal to WT because of the definition of midpoint, right? I know that V cuts SW in half, and I also know that W cuts VT in half. So by the transitive property of equality, I can say that the segment SV is congruent to WT. Okay, why don't you pause the video, take a moment, and try to figure this one out all on your own. Okay, if angle 1 and angle 2 form a linear pair, and angle 3 and angle 4 form a linear pair, then the measure of angle 1 plus angle 2 plus measure of angle 3 plus 4 equals 360 degrees. So, statement 1. So angle 1 and, angle 2 are a linear pair. That's given. We also know that angle 3 and angle 4 are a linear pair, and that's given. So that means that angle 1 plus angle 2, I don't need to write like that. It needs to be written measure of angle 1 plus measure of angle 2 equals 180 degrees, and that's because of the definition of a linear pair. All right, we know that a linear pair adds up to 180 degrees. The same is true here for the measure of angle 3 plus the measure of angle 4 equals 180 degrees, and that's also by the definition of linear pair. You could have combined a couple of these steps, that's fine. Let's see, step 5, all right. For step 5, I know I can say, okay, well, measure of angle 1 plus measure of angle 2 plus measure of angle 3 plus measure of angle 4 equals 360 degrees. And how did I get that? By simple addition. I just added this side, and I came up with this, okay? All right, again, pause the video, see if you can figure this one out on your own. Okay, angle 4 and angle 5 are supplementary, angle 5 and angle 6 are supplementary, prove that angle 4 is congruent to angle 6. Okay, so we're going to say angle 4 and angle 5, and angle 5 and angle 6 are supplementary because that's given. So that tells me that angle 4 plus angle 5 equals 180 degrees. And that tells me that angle 5 plus angle 6, why am I writing it this way? Hopefully you caught that. So measure of angle 4 plus measure of angle 5 equals 180 degrees. And measure of angle 5 plus measure of angle 6 equals 180 degrees. And that's both by the definition of supplementary. You could have combined those into one step if you wanted. All right, then I know that because we're both equaling 180, they have to equal each other. So the measure of angle 4 plus the measure of angle 5 equals the measure of angle 5 plus the measure of angle 6, and that's just by substitution. I think you can see where we're going from here. 5 and 5. All right, I notice that I have measure of angle 5 on both sides, so I end up getting measure of angle 4 equals the measure of angle 6, and that's just by addition or subtraction. Okay, then I also see, we'll do one last step. Okay, that because the measures are equal, angle 4 has to be congruent to angle 6. And that's because of the definition of congruent angles. Okay, now what we'll do tomorrow is we'll try to talk about these in terms of flowcharts so you guys can really get the idea of how these work together to make a flow chart, what's feeding into what, how we use all of this, okay?